Alright, in this video we're going to do some examples of solving differential equations. Up at the top I have some notes that I'm sure you have in your notes as well, but just a quick review of what a differential equation is. It's nothing more than an equation that has a derivative in it. When we solve a differential equation, what we're doing is we're finding the function that satisfies it. In other words, that's the equation whose derivative is the differential equation. 3 steps to solve the differential equation. First we separate the variables, then we integrate both sides, and then we finish by solving for y. There are times, many times, when they give you an initial condition and ask you to go one step further, and that is to find the c value. Okay, so we're going to start out with a real straightforward one, and then we'll move to some that are a little bit progressively more difficult. Okay, so the derivative dy dx is equal to negative 4xy squared. So we're going to move that y squared over to the left by dividing. We're going to keep the negative 4x over there and multiply the dx that's in the denominator on the left to get it over to the right. Alright, so that's the separation step. The integration step is to put a integral sign in front of those. We're going to integrate the left side using the power rule. So I want you to think about 1 over y squared as y to the negative 2 dy. So using the power rule, that becomes negative 1 over y. On the right side, the integral of negative 4x using the power rule would be negative 2x squared and then plus c. Technically both of these, when we integrate, have a plus c as part of them, but we're just going to consolidate and put both of the constants over on the right and refer to the constant as c. Alright, so now that we've separated, we've integrated, we need to just simply finish this by solving for y. And so first thing I'm going to do is I'm just going to multiply through by a negative, and so I get 2x squared plus c. Again, the constant is, we haven't solved for it yet, so we're just going to, even when we multiply through by a negative, we're still going to call it c. Last thing we want to do is flip both sides, and so we get y equals, and I'm just going to go ahead and put this in parentheses to the negative 1. Because there was no initial condition, this is our final answer. Okay, let's do an example with a trig function in it. So this time we're going to say dy dx is equal to 1 over secant squared of y. Alright, so step 1, separate the variables. So I'm going to bring the secant squared y over to the left, dy, by multiplying, and then I'm going to have 1 dx, that's an x, on the right hand side. Alright, so we've separated, now we're going to integrate. The integral of the secant squared is the tangent of y, and the integral of 1 using the power rule is x plus c. So to solve for y when we have a tangent, the operation we do to both sides is we take the inverse tangent, and so the inverse tangent of the tangent of y is y, and then we simply write inverse tangent of x plus c. So let's, for this one, go ahead and give an initial value. So let's go ahead and say when x is 3, y is 0. So you have a couple of choices. You can plug in that ordered pair anywhere after you've integrated. And so after you do a bunch of these and get really good at it, you'll find that sometimes it's not best to wait to the very end to plug in the ordered pair to solve for c. Sometimes it's easier to go back a step. And what you've recognized is, depending where you plug it in, you might get a different answer. So I'm going to go ahead and plug the 3, 0 into this equation. So over here I'm going to say that the tangent of 0 equals 3 plus c, and the tangent of 0 is 0, so c turns out to be negative 3. Okay, so when I plug the negative 3 in here, then in the next step the final solution becomes y equals inverse tangent of x minus 3. Okay. If we had waited to plug in the 3, 0 to here, then when we put the 3 in here and the 0 here, we have to go back and take the tangent of both sides. So we'll still get the same constant in this case, but it's a little bit more challenging to wait to the very end. Okay, last example. Oftentimes we find that when we integrate we need to use the natural log, so let's go ahead and look at this differential equation. Okay, so I have y prime is equal to y e to the negative x, and in order to separate the variables we always want to change a y prime to y dy dx. All right, so now I've got dy dx equals y e to the negative x, so I'm going to bring the y over by dividing by it, and the x over, keep the e to the negative x there, and then bring the dx over by multiplying. Sorry about that. So we've separated, now we're ready to integrate, and the integral of 1 over y is the natural log of y, and the integral of e to the negative x is e to the negative x, and don't forget the reverse chain rule there, so we have a negative in front and plus c. Okay? And so the way, if we are solving for y, and y is the argument of a natural log, then what we do to both sides is we make each side the power of e. Okay, so we're going to take e to the natural log of y, and we're going to take e to the negative e to the negative x plus c. So what happens here is we get y, and what happens here is we get e to the negative e to the negative x times e to the c. So I'll just put a little star here, and if you're confused with this, where it went from a sum to a product, I'll just say go back and look at your rules for exponents, and the exponent rule I'm talking about is if you have b to the x times b to the y, that you add the exponents. Right, so there's the adding of the exponents. All right, so e to the c is just another name for c, and so the answer to this equation, this differential equation, is that y equals ce to the negative e to the negative x, and we're done. Okay, those are 3 examples. I hope that by watching this video it's helped make differential equation solving a little bit more clear, and we'll see you next time.